Chapter 5, Part 1. Now we're going to look at cost behavior and high-low analysis. Now, Chapter 5 is a great chapter because it helps you do what-ifs. If you're thinking of starting your own business or you're in the middle of your business, it really gives you good ways to determine what to do or not do. Now, examples would be, say, how many units do you have to sell to break even? What sales volume is needed to earn a targeted profit? How much will income change if you buy a new piece of equipment or you reduce labor? And what is the change in income if selling prices decline? This is great, for instance, especially with our economy. Say things happen that are going to cut your production in half or double your production. It'd be nice to have an idea of what effect that's going to have on your facility and whether you can handle it. All right? Or product mix. A lot of times what people find is they might produce a product, maybe 3 or 4 products, but one of them is actually costing them to produce. So this kind of analysis, I think, is an excellent idea for helping you solve those kind of issues. Now, when we talk about cost behavior, remember, you have to be able to make these assumptions. So, how costs change as volume changes within the relevant range. Now, what we're talking about is the relevant range is if we have a factory that can produce 0 to 1,000 units, that's the relevant range. However, if you're going to produce more than 1,000 units, you're going to have to get a new factory, new equipment, and therefore all of these prediction changes because we're changing our fixed costs and we may even be changing our variable costs. Now, again, an example would be if you have a factory that can produce a maximum of 1,000 units, 0 to 1,000 is the relevant range. Now, when we work these problems, we assume we're always within the relevant range. So again, whenever you're doing this kind of analysis, you make a lot of assumptions, but it should be educated guesses. So the first thing we need to be able to do when we are looking at using cost behavior to make predictions is we have to be able to break our costs between variable and fixed. And this becomes an issue when we have mixed costs, which include a variable and a fixed element, and we'll show how you handle that too. So let's take a look at what does a variable cost look like. Well, first of all, it changes in proportion to changes in volume. So if volume goes up, total costs go up. So remember, we're only talking about total costs. But when we talk about variable costs on a per unit basis, they stay the same. Even if volume changes within the relevant range, once you determine your variable cost per unit, it is going to stay the same. But in total, it will change. Now, what do we do with fixed costs? Well, here's the difference. With fixed costs, total fixed costs do not change as volume changes within the relevant range. However, fixed costs on a per unit basis have an inverse relationship when volumes change. So, if volume goes up, the average fixed cost goes down. That's why we don't look at fixed costs we only look at fixed costs in total. We do not look at it in a per unit basis, and I'll give you an example why you don't do that. So here we have a problem. We are producing 120,000 units, and these are our fixed costs, and those are our total costs. So now what we're going to do is we're going to calculate our variable cost per unit, and then we're going to look at what it looks like at different production levels. So first, we know that fixed costs within the relevant range, we have to assume, this is an assumption, they're not going to change. Example would be like your rent, maybe depreciation on your equipment. That could be a fixed cost within the relevant range, i.e. 1 year, as long as you don't get rid of the equipment. All right, now what we're going to do is we're going to divide the variable cost by the number of units, and we get $1.25. So what we got to remember here, the assumptions are fixed costs don't change in total, And variable costs on a per unit basis do not change. You have to accept those assumptions in order for this analysis to work. So, what's our total cost of production at different levels? Now remember, our variable cost is going to change based on units, so we're going to take the variable cost per unit times the number of units produced to get the costs associated with each level of production, but our fixed costs stay the same. Now, as you notice, now we have our total costs. But if we were to divide total costs by units, we're going to get an average cost, and if you notice, as production goes up, average cost goes down. And that, again, is because of the inverse relationship for fixed costs. And the reason is, the more units they produce, the more we have to spread those fixed costs over. So let's take a look at this a little differently. So if we look at it on a cost basis, we know that our variable costs are not going to change. And here's what it looks like as production increases. So if you notice, at 75,000 units, it's only $4. Then it goes down to $1.88, and then it goes down to $1.07. That's your fixed cost per unit. Now, what does that mean? Well, if you used average cost for from the 280 units to price 75,000 units, what would that look like? Well, 75,000 units times $2.32, which is our average total cost, would tell you that it only cost $174,000. But look what it looks like when you use the contribution method. The truth of the matter is, it really costs $393,750. So, if you used only average costing, you would have undercosted those 75,000 units at $219,750. So that's why you have to be very careful not to use average costs in total without breaking out how much is fixed, how much is variable. Now, cost behavior. There are 4 ways that you can analyze or determine what the fixed and variable costs are when you have a mixed cost. You can do a count analysis, you can do scatter plots, you can do high-low method, which is the only thing we're going to cover in this chapter. If you want to look at the other methods, you can. Or regression analysis. We're not going to look at that either, okay? So, let's take a look at what does a mixed cost look like. What it means is, even if production goes down to 0, the costs don't go away. All right? Because they include both fixed and variable costs. Mixed cost is greater than 0 when volume is 0, and that's your fixed component, and increases steadily in proportion to increases in volume. That's your variable component. Now, how do you break that out? Well, we have a formula, and this is our cost equation. We're going to take our variable cost per unit times the number of units plus the fixed cost. So how do we solve for that? Well, we're going to do high-low analysis. And this is the easiest way to do it. Step 1, you're going to find the highest and lowest number of units. Remember, it's always units, not costs. And calculate the variable cost per unit. So there's our formula. Then step 2, we're going to find the fixed costs. Then we're going to create the cost equation. Total costs equal fixed cost plus variable per unit times volume. The advantage of using this method is very easy. The disadvantage is we're only going to use 2 data points, so it oversimplifies it, but it's so much easier than the other methods. And remember again, it's always the highest and lowest activity, not dollars. All right, so let's take a look at a problem. We have a cable provider, and what they want to do is bring in a new system that's going to increase their fixed cost by $81,800 per quarter, covering up to 1 million billings per quarter. Now, 1 million billings is the relevant range. Now, here's their cost data for the last year by quarter. So we're going to use high-low analysis to determine the variable and fixed costs. Then we're going to assume they project 740,000 billings to mail in the quarter that are projected to that 20% will be paperless. And what instead, if they assume that of those 740 billings, only 10% are paperless? What effect is that going to have on the bottom line? So the first thing we do is we're going to identify the lowest and the highest units. Remember, again, it's units. Then we're going to come up with our variable cost per unit, 70 cents. So we took the 750 minus the 592, 500, which is our high and low costs. And then we divide by our high and low units, which gives us an average for our estimated variable cost per unit of 70 cents. Now we're going to determine the fixed cost. Now I like to do it for both because then you make sure you're doing it correctly. So we use the highest cost, which is 750 minus 70 cents times 700,000 billings gives you 260 for the fixed costs. And then I do it with the lowest. And if you get the same numbers, you got a good chance you did it correctly. So that's the reason I always like to, when I'm doing accounting, I always like to come at a problem from two directions if I can, because you always want to check those numbers because you're taking this information to use further in the problem. You want to make sure it's correct. All right, so now we're going to do step 3. We're going to create our cost formula, which is we know our fixed costs are 260, and now we've got 70 cents per unit. Now, we are going to assume the project's 740,000 bills are 20% paperless. So the thing is, when we look at this, we're only going to look at the cost changes. So what if 20% bill reduction? We're going to increase our cost by 81,800, but what's going to be our reduction? And as you can see, if we can reduce bills 20%, we're going to save ourselves $21,800. Now, what if it's only 10%? Well, in that example, we're actually going to lose money. So probably we're going to want to make sure that we're going to see a significant 20% in order for this to be worthwhile. So now let's take a look at another example. All right, here we go. We're going to do our high-low analysis. First, what we're going to do is find our highest units, which is hours, and we're going to find our lowest. And then what we're going to do is compute our variable cost per unit. And that gives us $1.60. Now, step 2, we're going to use our equation. So we know that our highest cost using our $1.60 gives us $17.40 for fixed costs, or we use our lowest cost in the cost equation. We get the same number. Again, we're double checking, which means we're on the right track. Next, we're going to put it in the cost equation. Our fixed cost plus $1.60 times machine hours. And if 1,200 hours are used, the total estimated cost is going to be $3,660. Now, cost decisions. What you have to remember is you sometimes have what we call committed fixed costs. These costs cannot be changed in the short term. And then we have what we call discretionary fixed costs. More control over discretionary fixed costs because the companies can adjust the cost as necessary in the short run. Example would be advertising expense. We also have what we call stepwise costs, which they change as volume changes. Stepwise costs have a step patterning cost within a relevant range of current production. Relevant range is the normal operating range for the business. A good example would be rent. Rent, if there is an Stepwise would be if we add or drop a shift manager. Stepwise would be add or drop a production line, a warehouse, or sales region. Mixed costs would be sales reps, salary and commission, natural gas, maintenance, electricity, and water. They have a fixed portion. For instance, for water, you may get a base amount, and then it's based on usage. Variable, of course, is going to be all the costs we normally look at, and then fixed costs would be rent, property taxes, insurance, things like that. Okay, that concludes part 1